The tribology is a general term that refers to design, operation dynamics of the bearing, lubrication, and rotor structure machinery. The technologies of tribology became used to preventive maintenance. The most likely is causes for failure the machineries is the wear combined with the obsolete and accidents. Next. Okay. We will talking about the wear of the machinery's pieces. Here can you see the wear occurred due corrosion is here occurred the adhesive materials, and here occurred the friction. Then the wear can be normally or destructive, but any machine is immune to heat.
Which are the different types of wear? For example, the rubbing wear, the fatigue wear, and the wear by corrosion. The rubbing wear is the result of normal slaves wearing the machine. The fatigue wear arises by concentration of voltage greater. In the wear by corrosion, this is caused of inside of environment.
Scoffing wear is a severe addition, and is transferred to scuffing wear is a severe addition surface to another due to welding and tearing. The damage typically occurs in the addendum, the dendum, or both. And well, how can I identify that? Well, in this thesis, in the direction I need to
wear variation. The wear variation is produced the wear variation to surface for example, it is component for example, component with wear and component without wear.
Okay. Wear particle analysis. This analysis consists
to take an oil sample from a machine to observe in it. Is to observe it and see and see the particles inside, the wear particles inside of the oil, and how much this contained in the lubricant of the machine. The particles in the lube can tell us a lot of things of the machine, if this is in good condition or not. This information derives from the study of the particle shape, the size, or the quantity, the composition too. For the wear particle analysis comes in two methods, and the first method can be the routine monitoring and trending. This is practically to study the components, the particles inside of a lubricant of the machine. The quantity and the composition inside of the lubricant can tell us the condition of the machine. When the lubricant has low particles inside, that tells us that the machine is in good conditions. As a machine degrades, the particles will increase. There are three techniques to study to make these methods. One is the inline. In this example, we can see the three types in only one, but usually we're gonna have just one in one machine. So in the flow of the lubricant, there is a pipe, and is the inline wear. It's just it's monitoring with sensor, and that tell us only if the lubricant is dirty or not, or has the particles matter. In the second one is the online, and this function is with a bypass in here. This bypass, and we can see the turbidity of the lubricant. And the last one is the offline, and this is simple to take samples, different samples of the lubricant, and send it to laboratory to analyze. The second one is the analysis of particle matter, and in this we're gonna start the size and composition of the particles. So, and that's with the time we can make this graphic to see this charter to see the conditions of the machine, about the time that we are using it. This analysis is to prevent, in conclusion, this is to prevent the damage on the machine, so we can change the lubricant and extend the life of the particles of the bearing.
Scuffing damage is a severe addition. This addition or this scuffing damage can be prevent from this scuffing damage can be prevented through design related change. For example, in the design related change, we can optimize the design, or we can use some lubricants without high viscosity and with anti-scrap additives. In this picture, we can see the addendum the addendum, and this is the pitch line in this circle pitch. And in that piece, we can see the parts of the wear friction. In this part, we can find the addendum, and I hope you can see the pieces. And this is addendum, and this is addendum. The piece is the middle of the piece, and the line in the imaginary line is this. This is the pitch line. And when this piece is around the circle, is when the friction starts. Is when the friction or the wear friction starts.
Thank you.